So let's start looking at question 7 on paper 2, 2018. The line J has a slope coordinate geometry of 2 over 5. The line N perpendicular to J. Write down the size of the angle between the lines J and L. Well, one line that's perpendicular to another line. The angle between the lines is going to be all 90 degrees. So you might have got confused by the slope here and wrote minus 5 over 2, the perpendicular slope, multiplied by the slope itself will always give a product of minus 1. That's always the case with perpendicular slopes, doesn't matter what they are, so that's why you can turn one upside down, change the sign. The line N goes through the point 61. Write down the equation of the line N. So they haven't told you to get the perpendicular slope, but the equation of the line N is the perpendicular one. So just be careful that you didn't use the original slope in this question. Always write down the information you're going to put into the formula. M is equal to our new slope of minus 5 over 2. Our point, 6 minus 1. And then write down the formula, y minus y1, that you know off by heart, is equal to m times x minus x1. Y minus 1 equals minus 5 over 2 times x minus 6. You should be able to do this in your sleep at this point. Multiplying the left by 2, 2y plus 2, which is that 2 on the bottom, is equal to minus 5 times the right, minus 5x plus 30. It says here, you do not need to simplify your answer. Now, what does that mean in a mathematical question? I do not know. Can you leave it like this? Well, I would have, if we have a negative x, I tell you to bring that to the left. So we're going to get 5x, the 2y is already there, equals the 2 minus the 30, or equals 30 minus 2, I should say, which will be 28. Or you can have 5x plus 2y minus 28 is equal to 0, or you could have 2y is equal to minus 5x plus 28. So any of these answers will be correct, or some mysteriously non-simplified version of one of these. And just for your information, there was 15 marks for this question, and this I had to look and see what a non-simplified version of an answer was. This is what got full marks for 15 marks in 2018. Can you believe it? So the next part of this question continued with equation of lines. We need to find the slope and the point where it crosses the y-axis for both of these. So if you write any equation in the form y is equal to mx plus c, the coefficient of x will be the slope. So here the coefficient of x is 1. In the second equation, we'd need to put the 3y to the right hand side to make it positive. 3y equals, that would mean with the 2x will be left alone, and we bring the 6 across to meet it. So y would be equal to 2x over 3 minus 6 over 3. So the m of this line is 2 over 3. Put it in. And then, well, the y-intercept is when x is equal to 0. So when x is equal to 0 in the first equation, all you see, you just ignore the x, read what's left. Y is equal to minus 1. 0 minus 1. And for the second equation, if we let x equal 0 for this one, what will be left? 3y equals minus 6. So y would be equal to minus 2. Let's write that out for the examiner. 3y equals minus 6. Y is equal to minus 2. So we have the point 0, minus 2. Last part of question 7, the line K and the line L, find a point of intersection. Now what I would do is write them out in the same terms, so we have x and y equals a number always for these. So we're going to have x bringing the y to the right minus y would be equal to minus 1 being brought to the left, 1. And this one we have written as 2x minus 3y equals 6. Now, what do we want to eliminate? Well, if I multiply the top line by either -2 to get rid of x, or -3 to get rid of y, choose either. If we multiply this one by -3 and write the answer down here, we're going to get -3x plus 3y equals -3. Double check your signs, minus plus minus, and then if we add these together, we're going to get -x, the y's cancel, equals 3. 6 minus 3, so x is equal to -3. And if x is equal to -3, in this equation here, I just substituted in -3 for x minus y equals 1. The answer will appear eventually. So if we leave the -3 there, bring the 1 across to meet it, it'll be -1, and bring the y to the right, it'll become positive. So y is equal to -4. So the point of intersection of these two lines, you can just write POY -3 -4. Question 8, one of those probably, I think, difficultly phrased questions. If difficultly phrased question makes sense to you. The line H has a slope -2 and passes through the point 1, 101. Find how many points on the line have coordinates that are both positive whole numbers, including the point 1, 101, and justify your answer fully. So justify maths, let's do maths, and let's do a diagram here. I think we have a point on a slope, so let's get the equation of this line. Write your formula. You might not be sure where this question is going, but like if you have a slope and a point, write the equation of the line. -2 for the slope, and the point 1, 101. It's always good maths to write it out again. So y minus y1 is 101 equals m -2 times x minus 1. Y minus 101 equals -2x plus 2. So let's write it in the format 2x, bringing the x to the left, plus y equals, I'll bring the 101 to the right, and it's going to be positive, add it to the 2, 103. The reason I'm doing this is so I can sketch it. Let's get the intercepts. That was the previous question. When x is 0, y is going to be 103, as you can see from the equation. And when y is 0, working backwards, 2x will be 103, x will be half of that, which would be 51.5. So I'm just going to sketch this and see, does it help? Don't need much of the negative. So 0, 103 up here, and 51.010 is down here. So how many positive whole numbers? 0, 103 is up there, and 51.50 is down there. So now let's look back at the question. Positive whole numbers. So when x is equal to 1, let's just do an experiment here. When x is equal to 1, that will be just down here, 2 plus y is equal to 103. So y will be equal to 101. So the point 1, 101 is on the line, as they told us. We're just seeing the point 2. When x is equal to 2, this will become 4. And y will become 99. So the point 2, 99. So all the positive whole numbers work, didn't they? The point 3. Let's just double check that. 2 3s are 6. So y would end up being 97. And you can see a pattern here. So all the points 1 up to 51 will work. 52 doesn't work because 52 is passed here, but 51 will be here. So the answer to this question is going to be 51 points. And our justification is we've subbed in 3 of them that work, and 52 doesn't work, 52 not work. And that will be enough information for the examiner. in 2018. Question 9. We have a diagram showing a rhombus Q or ST. Q, just identifying the points, or S and T. It is a parallelogram in which all four sides are equal in length. So we can give them a little line there. All four sides are equal in length. The diagonals cross at the point K, and two of the angles are marked X and Y. So we have alternate angles straight away. We can see here with our Z. So we can put a Y in here. Just finish it off, and we could put an X in here. So Sanjay is trying to prove triangles QKT and SKT are congruent. Well, let me mark them and get rid of all this. QKT and SKT. QKT. Just so we can see them again, you draw this out again, and SKT. SKT. I'll just do it in a different color. Trying to prove that these triangles are congruent. Make this a double line. So fill in the missing statements and the reasons in the table below to complete Sanjay's proof correctly. So the first one is QST is an isosceles triangle. QST, Q, S and T. Well, we're told that these sides are equal. I'll give them double lines now. So therefore it is QT is equal to TS. Well, we're given that as well. QT is equal to QS, but an isosceles triangle have two sides the same. So it is isosceles. So I could write in two sides equal, QT is equal to TS. I know they've given it already, but we could also say these angles, the angles opposite these sides are equal X and Y. Is that the next part? Angle X is equal to angle Y. Angles opposite equal sides. Angles opposite equal sides equal in measure. I think is what they're looking for here. Just take your time with these reasons. The next, the diagonals of a parallelogram bisect each other, and we're asked to put in the statement. Just be careful with the letters. Q, K is equal to S, K. The diagonals of a parallelogram bisect. QK is equal to SK. That's what they're looking for this one. The last one, QKT, they're looking for QKT is congruent to SKT. That's side angle side that we saw above. Side angle side, therefore congruent. And I think that's the end of this question. Question 10. Grace is putting some stairs into a new house. The diagram on the right shows 3 of the steps in the stairs. Given information here, a riser and a thread, riser, thread, so on. So what's happening here? Each step consists of a riser and a thread. All of the risers and they're the same as each other. And the table below shows the measurements for the stairs in private and public buildings. The optimum length is the best possible length. A lot of information here. So thread in millimeters. Just to read the table carefully, this is the riser in millimeters. We've optimum, we've minimum and optimum, and we've optimum and maximum. And then we have private and public. So a lot of info going on here. Just take your time with these questions. Grace's stairs will have the optimum size for a private building. Well, here's private. And optimum, there's 2 optimums. This one here, so she's going to have optimum size for a private building. Grace's stairs will climb a total vertical height of 2.1, i.e. the sum of the risers is 2.1. The sum of the risers, here's the risers, they're going in this direction. The sum of all these is 2.1. Work out the horizontal length of Grace's stairs, i.e. the sum of the threads. So all of these guys going this way. So we just have to work out how many there are. So 2.1 is the total height, 2.1 meters. That's equal to 210 centimeters. You can see we're dealing in millimeters here, so immediately my brain is thinking convert everything to millimeters. 210 centimeters, 10 centimeters in a millimeter, so multiply by 10, 2100 millimeters is the total height. So how many risers? We'd have to divide the height of the riser into this. So dividing by the optimum riser, 175, gives a total of exactly 12 steps. And then we're looking for the width of the threads. So she's going to be using the optimum thread. Sorry, the optimum thread. So 12 by 250. 10 will be 2500 plus 500, 3000 millimeters. And if we go backwards to meters, that would be 3 meters, 2.1 meters high, 3 meters wide. Part B, trigonometry now. The angle of Grace's elevation is marked here, A, for the stairs. We said it was 2.1 meters high and 3 meters wide. We have the straight sides, so you know it's going to be tan. The tan of A is equal to opposite over adjacent, opposite 2.1 over 3. So we want to get the inverse tan to get the angle of 2.1 over 3. Write out what you're doing, show the examiner the inverse tan of 2.1 over 3 is giving me 34.9 degrees. Nearest degree, let's look back up always, 35 degrees for the angle of elevation. And the last part, we're asked to write down the length of the thread and riser that would give maximum angle of elevation for a public building. So obviously we're not just going to write them down, we're going to look at the diagram again and maybe write out a couple of triangles here. So the maximum angle for a public building. So public building, we have minimums and maximums, and we have optimums. So let's look at a little diagram here. We have the step climbing up like this. So we're actually not looking for the angle, which will be in here. Alternately will be in here. The tan of which is the riser over the thread. So we could have the riser could be 180. Just do another diagram again. It also could be 150. And the thread could be 280 or 300. Well, let's min and max this, 280 and 300. These would be the minimum and maximum values. So what were we asked? 280 and 180, I think. We were asked for the max angle. So actually we would work them out here. I think let's work these two angles out. We have a 180. Go back up and work them out up here. We have the inverse tan of 180 over 280, or we have the inverse tan of 150 over 300. What will these give? So doing both of these, I get 32.73 degrees, and this is smaller, this is 26.56. If you were asked to work out the angles, so the max angle would be this one, and this would be the min. So nice little question here to finish this video.